Good morning. This is Mr. Sensei, your stats sensei, and we're going to work on scenario 2 of the test review. So a financial analyst claims that the mean monthly expenses for a group of 2,400 investors is 3,000. So there's a claim, so that's mu equals $3,000, or that's likely to be our population mean, with a standard deviation of 657. A simple random sample of 40, so n equals 40. Investor shows a mean monthly expense of $2,850. So that's the X bar because it's coming from the sample, so 2,850 at an alpha 6% level. So they want us to test the hypothesis at a 6% level. So alpha is 0.06. So the first thing we need to do is write our hypothesis. That should be number 1. So HO, mu, it's always going to be equal. So in this case, mu equals the claim, which is $3,000. One thing to make sure that I say again, never ever use your X bar or your X bar values there. It's wrong. And so we have mu and we have 3,000. These will always be the same number and always the same mu. The key word here was less. So we want the probability that it's less than $3,000. Our parameter will be let mu equal the true population mean monthly expense for investors. And if you just stopped at monthly expense, that's great. All right, our conditions. The first condition is always random sample. We have a random sample of size 40, and that was given. Number 2, the n is less than 10%. Well, n equals 40, and 40 times 10 equals 400, and that's less than the 2,400. So we can put check marks by both of those. Normality. If they told us it was normal, we wouldn't have to do anything other than say normal given. But in this case, they didn't tell us, so we don't know the shape of the distribution. Some people may have extremely high expenses. I don't know. But n equals 40, which is greater than or equal to 30. We always compare to 30. So this is normal or approximately normal by CLT, by central limit theorem. Our formula, Z equals X bar minus mu standard deviation divided by the square root of n. Then we need to draw to see what it looks like. Well, in this case, 3,000 is the claim mean, and until we find otherwise, we have to accept it. We have a X bar of 2,850, and we're shading this direction. So if my mean is 3,000, my X bar is 2,850, my standard deviation is 657, right there. And my N was a sample size of 40, and we said it was a less than, because that's what our alternative hypothesis indicated. So now we're going to plug these values into our formula. And so we'll have 2,000. So we want the probability that Z is less than 2,850 minus the 3,000 over 657 divided by the square root of 40. So we want the probability that Z is less than that stat test. Number one is Z test, 3,000. Our standard deviation is 657. Our X bar is 2850. Our sample size is 40, and we wanted less than. We press calculate, and we end up getting negative 1.44. So the probability that Z is less than negative 1.4439, and that equaled a p-value of 0.0743. All right, so 0.0743. So if our p-value is 0.0743, our alpha is 0.06. This is greater. When it's greater, we fail to reject. So our conclusion is simply our p-value is 0.0743. We fail to reject the null. There is not, if we would have rejected, we would have said there is, but since we failed to reject, there is not enough evidence, there's not sufficient evidence at alpha equal 0.06, and you can write the word alpha if you like, to suggest that we have to restate our parameter, the true population mean monthly expense. Is, and our alternative was less than 3,000. That's what we always, whatever our alternative is, that's what we include here. So is less than $3,000. So while our sample mean was 2,850, which is less than 3,000, we don't have enough evidence to say that on average, the average is less than 3,000. We just have enough evidence to say, but we do have some, we just don't have enough at the 6% level. All right, so we can't reject that at the 6% level. All right, the next one, we're gonna go on and do a confidence interval for scenario one, because it says calculate a 94% confidence interval for the mean monthly expenses and comment on whether there's enough evidence to support the claim that the expenses are less than 3,000. I'm going to go ahead and rewrite the parameter because I will use that in my conclusion. So let mu equal the true population mean monthly expenses. The conditions, I'm not going to rewrite them because they're the same as what we had before. First one, random sample of 40 was given. That had a sample size of 40. Our sample size is 40, and 40 times 10 is 400. That's less than the 2,400, so that was taken care of. And our sample size of 40 was greater than 30, so it's normal by central limit theorem. So I'm not going to rewrite those. But our equation happens to be X bar plus or minus Z star standard deviation divided by the square root of n. Our standard deviation was 657. Our X bar was 2,850. Our n was a sample of size 40. and they wanted us to calculate a 94% confidence level, so this is 0.94. And I got all of that information from up here. There's my standard deviation. 2850 was my X bar. And there's my simple random sample of size 40. Okay, calculating Z star. So I draw my little picture. And we need a 0.94. We're centered on a mean of 0 because this is a Z and all Z's have a mean of 0. So inverse norm 0.94, 0, 1, and we're centered. So we're going to go on there and go second vars, inverse norm, area is 0.94, mean is 0, standard deviation of 1, make sure we're centered. And we calculate and we get negative 1.8807 to 1.8807. So negative 1.8807 to 1.8807. Then I'm going to plug my information into my formula. So X bar was 2850, 2850, plus or minus my Z star, 1.8807. We always want to use the positive. Why? Because we already have a plus or minus as part of the formula. My standard deviation is 657 over the square root of 40. So when I go to calculate my interval, I'm going to go stats test Z interval, which happens to be number 7. Here, stats test, scroll down to number 7. Stats is highlighted. My standard deviation is 657, 2850, 40, and make sure I have a confidence level of 0.94. But when I do that, I get 2654 to 3054. So 2654.6. So $2,654.60 to $3,045.40. So then we get to write our conclusion. So in repeated, we are 94% confident that the true population mean monthly expense lies within the interval 2654 to 3045. All right. Now, the meaning goes, okay, if we're going to do this over and over again, how likely is this going to happen? Well, if we did it over and over again, that means if we sampled over and over again. So in repeated sampling, we expect this method to capture the true population mean monthly expense. How much of the time? 94% of the time. Okay, last part of this. It says comment on whether or not there's enough evidence to support the claim that there are less than $3,000, that the expenses are less than $3,000. Well, when I look at it, like, well, we cannot say it's less than 3,000 because 3,000 lies within the interval, because the interval extends from 2654 to 3,045. So the interval is definitely wider. So $3,000 is in there. So we can't say that it's less than $3,000. All right. So basically, no, we cannot say it's less than 3,000 because 3,000 lies within our interval. All right. I appreciate you watching, and I hope to see you on the next one. Thank you.